Welcome to this video on asymptotes. We're going to take a question which is y equals x plus 1 over 3x minus 2. And the first part we're going to do is find the coordinates where the curve crosses coordinate axes. Now then, what this means effectively is when x is 0, what is y, and when when y is 0, what is x. Hence you can see what I've written below. Now the way in which we do this is very simple. We substitute it in. So when x is 0, y equals 0 plus 1 over 3 lots of 0 plus minus 2. Therefore we know that y is equal to minus 1/2 when x is 0. So our point will be 0 minus 1/2. Now when y is 0, we make 0 equals x plus 1 over 3x minus 2. Now what this effectively means is we need to get each of these lines to equal 0. So if x plus 1 equals 0, x must be minus 1, and when 3x minus 2 equals 0, x must be 2/3. Now as minus 1 is smaller, that is the x value that we will use for this. Therefore it's minus 1, 0. Now that is the first part of our first part of the question done. So quickly to recap, what we have done is we have worked out when it crosses the coordinate axes that's when y is 0, when x is 0, and have thus substituted x is 0 into the equation, and also when y is 0 we have found out what the smallest value of x is going to be. Now then, part B is find asymptotes. Now I probably at this point should explain what an asymptote actually is. An asymptote is if you've got a coordinate axis, so here an asymptote is basically a curve like that which never touches the axes. That's probably the simplest way of defining an asymptote. Now as you can see, we've got to find the asymptote. Now we have, I'll just rewrite the equation quickly, y equals x plus 1 over 3x minus 2. Now then, the way in which we find our x value, because we obviously need the asymptotes on the x and the y, is if we take just 3x, if we take the denominator, 3x minus 2 equals 0, then we know that 3x equals 2, x equals 2/3. The x equals 2/3 is our vertical asymptote. So that's the main bit. So in order to find out the x value of our vertical asymptote, we simply take the denominator, make it equal to 0, and work out our value of x. Now to find out our y, our y asymptote, our y-axis, we must do things slightly differently. So rewrite the equation again, y equals x plus 1 over 3x minus 2, and we divide everything by x. I'll show you what this looks like. So first of all we have x divided by x, which is 1, plus 1 over x over 3, because 3x over x is 3, minus 2 over x. And what we can do here is we can make x infinitesimally large, and therefore what this means is that effectively the numbers become so small that we can ignore them. So when x tends to infinity, y equals 1/3, and y equals 1/3 is our horizontal asymptote. Now, give me a sec. Horizontal asymptote. So quickly, just to recap, what I have done is in order to find the x asymptote, I've taken the denominator, made it equal to 0, and found out what the value of x would be. And for the value of y on the asymptote, what I've done is divided the whole lot by x and made x really, really big, and so to see what was left on for y. Now part C says to sketch the asymptote. Now I'm not going to properly sketch it because I think you can all probably sketch what an asymptote looks like, but I'll give you the general shape. So if I just draw a quick coordinate axis, this is a rough sketch. I mean, one thing that would be very much advised is to buy a graphical calculator and plot these, because you will get the asymptote much clearer, and you can also work out where the points are. Excuse my badly drawn axes. Now you know that when x is 2/3, so we'll say that here x is 2/3, you've got your first line, and when y is 1/3, you've got your second line. Now what this means is that the asymptote can't touch the dotted line at all. Now we've got our 2 points, which is 0 minus a half, so we'll put that there, and also -1, 0. As you can see, they're both on the negative side, and so if we draw our asymptote, then it'll look something like that, which means it'll look something like that over there. Thank you very much for listening. Hope you found this useful.